Every cell in the human body operates on a precise 24-hour internal timer, coordinated by the master clock in the brain's suprachiasmatic nucleus, alongside peripheral clock genes in organs like the liver, pancreas, and gut. Human physiology evolved to process nutrients during daylight hours, when metabolic rate and tissue insulin sensitivity are naturally highest. In the late evening, as darkness approaches, the pineal gland releases melatonin to prepare the body for sleep. Crucially, melatonin receptors on pancreatic beta cells signal a natural reduction in insulin secretion. When we consume heavy meals late in the evening, high circulating glucose coincides with diminished insulin responsiveness, leading to prolonged post-meal blood sugar spikes and elevated nocturnal triglycerides. Finishing your final meal earlier in the evening aligns nutrient delivery with your natural circadian metabolic window, though individual benefits depend on overall sleep timing and dietary quality. When you finish eating earlier in the evening, such as around 6 p.m., within the next several hours, digestion and nutrient absorption gradually decline. As blood glucose levels settle, the pancreas decreases insulin output and increases glucagon release. By midnight, several hours into your fast, the liver begins breaking down stored glycogen into free glucose to maintain stable blood sugar levels. As overnight fasting reaches 10 to 14 hours, liver glycogen reserves diminish significantly. This drop in circulating insulin disinhibits hormone-sensitive lipase, signaling adipose tissue to release free fatty acids into bloodstream. The enzyme AMP-activated protein kinase, or AMPK, acts as a cellular energy sensor, upregulating mitochondrial fatty acid oxidation and promoting a subtle rise in circulating ketone bodies, such as beta-hydroxybutyrate, providing efficient fuel for muscle and brain tissues. Beyond energy metabolism, extended overnight fasting triggers fundamental cellular maintenance mechanisms. When circulating amino acids and insulin remain low, the cellular growth regulator mTOR is downregulated, permitting the activation of macroautophagy. Autophagy is a physiological process where cells sequester damaged organelles, misfolded proteins, and cellular debris into autophagosomes for recycling. While dramatic autophagy increases are well documented in rodent models after prolonged fasting, human clinical evidence relies on randomized controlled trials evaluating early time-restricted eating, or eTRE. Human RCTs conducted over 5 to 12 weeks report modest improvements in 24-hour average blood glucose, systemic blood pressure, markers of oxidative stress, and systemic insulin sensitivity, though individual outcomes vary based on baseline metabolic health and total caloric intake. Finishing meals earlier in the evening also supports nocturnal recovery and sleep architecture. Late-night digestion requires active gastrointestinal blood flow and peristalsis, elevating core body temperature and interfering with deep slow-wave sleep. Resting the digestive system before bed allows core temperature to drop naturally, facilitating deeper restorative sleep cycles. Furthermore, nocturnal pulsatile release of human growth hormone peaks during deep slow-wave sleep. Because elevated blood sugar and insulin can blunt growth hormone secretion, entering sleep after several hours of fasting may support natural growth hormone secretion patterns, aiding cellular repair and tissue maintenance. Additionally, reduced nocturnal gastroesophageal reflux improves overall sleep continuity and esophageal mucosal health. In conclusion, finishing food intake earlier in the evening offers a clinically supported strategy to align nutrition with human circadian biology, enhance overnight metabolic flexibility, and support systemic health. However, researchers emphasize that meal timing is not a rigid universal cutoff. Benefits depend on individual circadian schedules, sleep timing, total caloric balance, and overall dietary quality. Focusing on nutrient-dense whole foods during your eating window ensures adequate protein, micronutrients, and essential fats. Individuals with diabetes on glucose-lowering medications, pregnant women, or those with a history of disordered eating should exercise caution and consult healthcare professionals. When adapted thoughtfully to individual daily schedules, early time-restricted eating serves as an evidence-based tool for long-term health and vitality. Medical disclaimer: this video is for educational and informational purposes only. It does not constitute medical advice, diagnosis, or treatment. Always consult a qualified healthcare professional regarding personal health conditions, fasting protocols, or dietary changes.